Hi friends, welcome to Sigma Maths. So today we're going to learn modulus argument form of complex number. Let's say we have g equals to x plus iota y. So if we plot this on Cartesian plane, we know that in Cartesian plane real part is plotted on x-axis and imaginary part is plotted on vertical axis, y-axis. So if we plot g equals to x plus iota y, so this length gonna be x length and this length gonna be y. Okay, so now see, this is a right angle triangle, right? So by using Pythagoras theorem we can easily say this length, which represents basically modulus of g, is root under x square plus y square. All right, now see, to represent this line we need to represent this vector, we need this length, which is mod of g root under x square plus y square, that's the modulus, an argument which is basically angle, right? So this angle we have to know. Okay, so to find this angle, it's very simple, it's right angle triangle. So we can say argument theta equals to tan inverse of y upon x, which is basically y. On y axis we have imaginary part of g, so tan inverse imaginary part of g upon x, which is real part of g. So real part of g is the argument, right? We'll discuss more about argument later. So how to write this? Okay, so like if can I say let's calculate sine theta and cos theta for this right angle triangle. So what is sine theta? So sine theta is opposite upon hypotenuse, so that's y by mod g. So from here I can write y equals to mod g sine theta, and cos theta if I calculate, so cos theta is adjacent upon hypotenuse, so x upon g, so x equals to mod g cos theta, right? So see, what was g was x plus iota y, so now we can write x is mod g cos theta plus iota y, and y is mod g sine theta. So this is our, we represent here in modulus argument form in terms of r. So r equals to mod g cos theta plus iota g sine theta. So we can take mod g common and we have cos theta plus iota sine theta. Okay, so that's how we can represent. Okay, now this argument, okay, this argument is, it should be between minus pi to pi. Okay, this is also called as principal argument. Okay, so basically here modulus, nobody will have confusion. Little bit confusion is there for students, that is argument. Principal argument is one of the confusion, so we'll discuss more about what is principal argument and how to find. See, the principal argument can vary from minus pi to pi, right? So we know that minus pi is when measured clockwise, and pi will get positive angle when measured anti-clockwise, right? Okay, so when we have, like if you have any g, let's say in first quadrant, okay, then you can just write r equals to mod g, okay, cos theta plus iota sine theta, where theta will be just tan inverse of imaginary part of g upon real part of g for first quadrant. But for the second quadrant, see, this will be theta, but our argument will be this actually. That's our argument, right? So here theta will be, we know that this, here we have 0 and here we have pi, so it's pi minus theta, where theta is just tan inverse imaginary part of g by real part of g, okay, without sign, don't take sign, without sign, right? So we get theta equals to pi minus theta into, so pi minus theta, Okay, where theta you can calculate by, let's call it alpha to remove the confusion. So alpha is argument here, which is pi minus theta. Here it will be just you will get as minus theta. So theta you just calculate tan inverse imaginary upon real, but with sign. Okay, here you take with sign. Okay, actually what happens in calculator cannot differentiate between, okay, 2 by 3 and minus 2 by minus 3. Both are equal for the calculator, but when it's 2 by 3, it's like x2 and y2 and x3, because we write y upon x. So y2 and x3, it's in first quadrant, whereas minus 2 and minus 3 is third quadrant. Similarly, minus 2 by 3 is equal to 2 by minus 3 for calculator. So you get answer either in first quadrant. This is minus 2 by 3, which quadrant? It's fourth quadrant, and this is second quadrant, right? So our calculator cannot differentiate, so that's why we need to calculate theta manually for second quadrant and third quadrant. Okay, but for first and fourth quadrant you will directly get in calculator. You just put with sign for first calculator for first quadrant and fourth quadrant, but for second and third, first you calculate argument. Okay, by taking just, you don't put sign. Let's say if you have minus 2 by I will do some questions also. So when it's minus 2 plus 3 iota, you just calculate 3 by 2, not 3 by minus 2. For which quadrant? For these two quadrant. Okay, so let's do one questions. And okay, so let's say we have g equals to minus 2 plus 3 iota. So if I plot in a Cartesian plane x minus 2 and minus 3, this is minus 2 plus 3 iota, where this length is 2 and this length is 3, right? So mod g is very simple. It's root under 2a square plus 3a square, which is root 13, right? And this angle I can calculate. This angle will be tan inverse of 3 by 2. Don't take sign. Okay, don't write 3 by minus 2. This if you do in calculator, so shift tan inverse 3 by 2, it's coming as 0.983, right? So our argument, principal argument will be, is this actually. Okay, so this total angle is pi. So see this total is pi, and from this we'll subtract theta. So argument is pi minus theta. So pi minus 0.983. Okay, so if we do pi minus answer, it's coming as 2.15 2.159 you can write. Okay, 87 is over. 2.159 will be the argument. So what will be r will be mod g. So root 13 cos theta 2.159 plus iota times sine 2.159. Okay, so let's say if we have in fourth quadrant, so mod g equals to minus 2 minus 3. Okay, minus plus 2. If we have plus 2 and minus 3 iota, right? So this is simple, right? It's in which quadrant? It's in fourth quadrant, x positive and y negative, right? So r is simple, r will be same root 13, but here argument will be just tan inverse of minus 3 by 2, because our calculator can easily give answer in first and second quadrant, first and fourth quadrant. So tan inverse minus 3 by 2 will be minus 0.983, right? So your r will be root 13 times cos of minus 0.983 plus iota sine of minus 0.983, right? Okay, we'll do one question even in third quadrant, right? So let's say we have question as minus 2 minus 3 iota. So r we know, mod of g we know. Mod of g will be root 13. Okay, so but here alpha will be, see, it's this actually, right? So your argument is basically this, right? And this value is 0.983. Okay, how we calculated that? This we calculate again, same tan inverse of 3 by 2. I don't take sign. Okay, you just put in calculator, you'll get this much. Now, so alpha will be what? See, from here to here is minus pi. So you have to go back. So you have to add actually, right? So minus pi plus theta. So that's why minus pi plus 0.983. Okay. So if I do that, we are getting as minus 2.158. Okay, 1.9 can write. Okay. So your R will be root 13 cos of minus 2.159 plus iota times sine of minus 2.159. Simple. Thank you.